If there are hostile alien civilizations in our galaxy, and we've been loud in the void for decades, why are we still here? The dark forest theory says we should be hiding. Yet, even if we did, our atmosphere has been glowing with signs of life for billions of years. In fact, Earth may have already been struck by relativistic weapons in the deep past. So, if another preemptive strike is on its way, can we survive it? A popular argument against the dark forest hypothesis claims that hiding is futile because alien civilizations could detect our technosignatures the same way we attempt to detect them on exoplanets today. According to this view, even if we fell silent, advanced observers could still identify our footprint on Earth. This argument sounds persuasive, but only because it assumes that observation is free, that one can watch without being seen. In reality, detection is not a neutral act. To scan the entire galaxy for faint technosignatures across interstellar distances requires immense, persistent, and energetically expensive infrastructure. An undertaking of such scale cannot be hidden. Any civilization capable of monitoring large volumes of the galaxy would necessarily be producing technosignatures of its own, stronger and more revealing than the signals it seeks to detect. In a galaxy with any amount of hostile civilizations, this would be self-defeating. The act of watching would be indistinguishable from the act of announcing one's presence. Every radio telescope, no matter how advanced, is subject to the inverse square law. As electromagnetic signals propagate through space, they spread out and weaken rapidly. What begins as a focused emission at its source becomes a vanishingly faint whisper by the time it has crossed even modest interstellar distances. To detect unintentional technological leakage, signals like control radar or routine planetary communications from star systems within a radius of 50 light-years would require a receiving surface the size of Central Park in Manhattan. And even such monumental effort would grant visibility into only a microscopic fraction of the galaxy, amounting to far less than 1,000% of the Milky Way. Scaling this search even slightly transforms difficulty into impossibility. To monitor merely 1% of the galaxy's stars for comparable leakage would require a collecting area equivalent to an entire country like Jamaica, or an array of smaller instruments covering the same total landmass. Such a structure would not be subtle. To any sufficiently advanced observers like us, such an installation would appear as a persistent, narrowband signal, a sharp spike at a specific frequency that no natural process can produce. Even if the telescope were not pointed at us, the sheer scale of the structure would make it detectable through side lobe leakage, unintentional radiation inevitably spilling out in all directions. This creates a fundamental catch-22 that applies universally regardless of intent. A civilization that limits itself to small concealable instruments can remain hidden, but is effectively blind beyond a tiny local bubble. A civilization that attempts to see farther must accept visibility as the price of knowledge. There is no intermediate regime in which one can quietly survey large swaths of the galaxy without simultaneously announcing one's own existence. As a result, every civilization is constrained to scanning only a negligible region around its home system. Anything beyond that horizon remains indistinguishable from silence, not because nothing is there, but because looking farther would be tantamount to self-exposure. Even if hostile civilizations exist, they are blind by necessity, constrained by the same physics and incentives that govern everyone else. Silence, in this sense, is not evidence of absence, it is evidence of equilibrium. The question of biosignatures, on the other hand, takes on a very different character. When we search for biosignatures, we do so by examining exoplanet atmospheres for specific molecules associated with carbon-based life, because that is the only form of life we know. But this is our own bias, not a cosmic rule. If carbon-based life is not the only form of life, then any molecular signature could, under the right conditions, be a byproduct of some form of life. In such a universe, biosignatures lose all strategic meaning. If life is ubiquitous, then treating life itself as a threat would require the systematic destruction of every planet and moon in the galaxy. Even if some civilization were capable of such devastation, it would reveal itself by remaining the only intact planet in the devastated region of space, becoming an unmistakable beacon to the rest of the universe. Once again, the strategy defeats itself. This is why preemptive strikes would be reserved for a very specific category of targets, those that reveal themselves either unintentionally through large-scale engineering or intentionally through a deliberate attempt at contact. Ironically, this is precisely what humanity has been attempting to do since the launch of the Voyager probes and recent high-powered broadcasts. And while highly focused broadcasts are dangerous, Voyager probes will never reach any alien civilization. When Voyager 1 launched in 1977, it was aimed toward Gliese 445, a star 17 light-years away. But to answer why it will never get there, we first need to understand a concept called the waiting game. While Voyager's speed of 17 kilometers a second might seem fast to us, by cosmic standards it's painfully slow. Humanity, meanwhile, is accelerating its progress at a breakneck pace. We've gone from the Wright brothers' first powered flight to interplanetary probes in just over a century. Within another few hundred years, perhaps even within this century, we will have propulsion systems capable of crossing 17 light-years, not in tens of thousands of years, but in mere decades. By the time Voyager gets anywhere close to Gliese star system, future generations of space probes will already have cruised past it, traveling hundreds of times faster. Voyager will no longer be a pioneer leading the way into the interstellar dark. It will become a relic, the most valuable relic in human history. Right now, of course, it's unimaginably far away, more than 150 times farther than Earth is from the Sun. To put that into perspective, if Earth were the size of a basketball, Voyager would be more than 5 miles away. Even if we sent the fastest spacecraft ever built, the Parker Solar Probe, which at its closest approach to the Sun reaches speeds of about 120 miles per second, intercepting Voyager would still take years. But the impossible doesn't stay impossible forever. Emerging propulsion concepts could radically change the equation. Nuclear fusion drives, like those being developed by Pulsar Fusion, a leading UK-based company, may one day accelerate spacecrafts to staggering speeds. Not just tens of kilometers per second, but eventually thousands. At those velocities, the gulf between Earth and Voyager 1 shrinks dramatically. Instead of decades or centuries, an intercept mission could reach the probe in months. Once such technologies mature, matching Voyager's velocity will become routine, and capturing it will no longer be a perilous maneuver. Instead, it would feel like a side quest, a straightforward task for a civilization already cruising between the stars. And this is where inevitability enters the picture. When interstellar travel becomes routine, leaving Voyager adrift will be unthinkable. It would be like leaving the Apollo 11 lunar module to crumble in a desert. Its historical value will dwarf that of any artifact on Earth. No future civilization will allow such a treasure to drift forgotten in the cold of interstellar space, especially when bringing it back is a simple side job. If, despite all this, we have already been detected and a preemptive strike is on its way to Earth, then no planetary defense can save us. A strike of that kind is not a weapon in the conventional sense. It is an extinction mechanism. Survival under such conditions cannot mean protecting Earth itself. It can only mean ensuring that humanity is no longer confined to a single target. The only viable response is to become multiplanetary. By spreading human civilization across multiple worlds, we break the logic of single-point annihilation. Mars colonies and lunar settlements, as well as habitats elsewhere in the solar system, would ensure that the destruction of Earth does not equate to the end of humanity. For more on the Dark Forest, this playlist covers many key theories that are often overlooked. It's a growing collection, with new videos added over time.